Let's investigate the masses of the hierarchy of leptons. And so first we have here the tau lepton, and its composition will be of a generic neutrino and a boson minus. Now, the initial mass, or assigned mass, for the generic neutrino will be 125 hundred thousandths of an electron unit. Now, if we look at the combinatorial values here, we see that we have a minus times a minus, which will give us a positive. So we would expect an increase in the mass due to the mass factor on the scalar boson minus. And so since this is a boson minus, we will expect it to first convert the neutrino into, in this case, a muon neutrino, since this is the generic ones are always associated with the middle generation. And then that muon will then be multiplied by the appropriate mass factor. And so let's see what we get. We get that the tau lepton has a mass of 4,000 lepton units. Now, let's continue and we'll see if we see a pattern. So again, we have the generic neutrino, or we can say the muon neutrino. And again, we can see that the mass is 125 hundred thousandths of an electron unit. And this time we have a boson 0. And so we should expect, since we have a negative times a negative, an increase for the tau neutrino. And we do. And we get 25,000 of an electron unit for the tau neutrino. And if we look at these two, the 4,000 electron units and the 25,000 electron units, we will find that the mass factor between these will be 160,000 electron units. That being, if I divide 4,000 by 160,000, then I should get 25,000. We will see that for each generation, that the mass factor between the charged and uncharged lepton will be 160,000 electron units, which is comparable to the mass of the W boson. So let's look again here at a configuration that will give us the mass on the muon. And so again, we would start off with 125 hundred thousandths on the generic neutrino, and then this boson minus, which has an combinatorial value of 0, so therefore does not and give us a mass factor on the scalar boson. Also, it doesn't give us a mass factor since the only combinatorial value in the system is those given by the generic component. And so we have 200 electron units on the muon, which is comparable to what is predicted by the standard model. Now, let's go here, and we have essentially again the muon neutrino. And I said previously that there was a mass factor separating the tau lepton from the tau neutrino of 160,000 electron units. That will also be the case for the muon neutrino and the charged muon. That the mass factor separating these values is predicted to be 160,000 electron units, which is comparable to the mass of the W boson, and therefore the mass of the weak interaction particle of the generation. And so there you have this schema not only providing a way of predicting comparable masses for the higher and middle generation of the particles, but also predicting a mass factor within a generation of 160,000 electron units, which is comparable to the W boson. $125 hundred thousandths